Welcome to the Rich Report, a podcast with news and information on the world of big data. Today my guest is from Quantum. We have Skip Levens. He's the Director of Technical Marketing at the company. Skip, how you doing today?
Doing great today, Rich. How about yourself?
Oh, great. You know, it's coming off a very busy time for us in the HPC world, but from the supercomputing show. But I'm glad we had a chance to talk this week and learn more about StorNext. The Appliance product you have. Yeah. So why don't we go into the slide, Skip, and then we'll do a Q&A at the end.
Oh, perfect. Okay, well, so let me dive in. But first, I'll just explain a little bit about Quantum. Quantum are a leader and have a number of solutions, in fact, call it a platform for the big data market. And we tend to look at the entire industry of everyone wrestling with big data as a few individual segments. Primarily, Quantum is best known for media and entertainment, the sort of classic big data, 4K movies, etc. But other customers and other very important segments are the federal and the federal space, and that would include intelligence, people wrestling with petabytes, approaching exabytes of data that they need to make sense of. And then there's the more traditional investigative and research-oriented life sciences and natural resources, and those are all Quantum customers. And Quantum's been in business for about 20 years developing these products. They, believe it or not, at one point actually made hard drives. In fact, if you ever owned a TiVo, probably the first hard drive that came in it was from Quantum. But since then have been more and better known not only for the StorNext file system, which is a cross-platform collaborative shared file system, but also for a range of products that help take data that you would share in a file system and archive it across a number of tiers. To the point that today we have a range of appliances that will store data, disk, RAID type disk, in a number of configurations, out to tape and deduplication products, and so a whole range of products that help customers either drive great solutions on or help tame the cost of big data. So that's Quantum in a nutshell. But what I'd love to do today is just kind of step through a few of the observations that our customers are coming to. We work with some incredibly well-known brands and companies across all these industries, and we find that where the customers are having the largest need and having to cope with the largest need is where you learn the most. It's almost like race car driving. It's where Ford probably doesn't make a penny on their racing operations, but that's where they learn a tremendous amount that they pour back into manufacturing. And that's really the way we look at it too, where we're helping customers at the most extreme end of the performance curve is where we learn the most. And a number of observations are coming to light. And in fact, it's driven a lot, and it drives a lot of our product choices, a few new ones of which I'll share in a moment. So on slide 2, we find that for our customers that their workflow has changed, not only in the kinds of things that they're working on, but also in the way that they work with the data. That today they're collecting and gathering huge amounts of data that is all digital, meaning that it's very easy to ingest at a rapid pace. You tend to do it from a lot more input sources, and so that has its own challenges on the ingest side. And then you have, and then depending on the segment, you have all that data, and you need to rapidly transform it and give value to it. So in media and entertainment, for example, that would be editing down to a reality TV show. It would in other groups, it would be sifting through a tremendous amount of data, looking for something that's one particular piece of information. But the actual workflows and the way people work is now no longer a nice neat order of workstations. You could be pulling in users that follow the sun, which means you need to really build a global workflow. And similarly, the data that you work with isn't all one size and isn't very predictable. It's all different sizes. It could be huge contiguous files or lots of very small files. And we're also finding that our customers are needing to, because of those changes, needing to take that data and be very flexible with the way they connect their users and the way that they connect the transports and the way that they connect all these users. So on slide 3, we to meet that need, we've developed a number of products, especially StorNext5, which is an all-new version of our well-known cross-platform concurrent shared file system called StorNext. It's called StorNext5, and we will be releasing a number of appliances that make tremendous use of all the improvements in StorNext5. So on slide 4, we looked at our StorNext file system, which is enjoyed by perhaps 80 to 90% of the media entertainment market, for example, and how customers were using it, and decided that we wanted to reinvent it, well, perhaps not reinvent it, but engineer it for performance from the ground up. The file system itself has been around on the order of 18 years, and obviously serves a lot of customers very well, but this was an opportunity for us to really take a look at each component of the file system and engineer it in something that would be a platform for us for many years to come. So we looked at everything in the internals of the file system, how it literally keeps track of users that are on different platforms, and what their access to storage is, and how they share files, and re-engineered all the internals to take full advantage of the new multiple processor chips to be highly multi-threaded, and then the representation of the user data and user interactivity on disk. That is now much more compact in a fresh new on-disk format, and it lays the foundation for a lot of exciting ways that we want to take take StorNext. So on the next slide, one of the benefits was when we engineered the file system for performance, it turns out that we got a tremendous amount of scale to go along with it. So when we're more efficient in how we keep track of and how we manage the file system, it turns out we got a tremendous amount of scalability as well, up to in the order of 5 billion files, which really sounds like a lot. However, as customers start having larger and larger teams of people working together, and those become global, then it's not inconceivable that customers can start approaching that. So on the next slide, obviously we did focus on performance. It yielded tremendous improvement across the board of how all the files that could feasibly be opened by, say, hundreds of connected clients all using the same storage volume at the same time, customers that create and write and delete files, all of that performance gets tremendously faster on the order of 10x. And even though media and entertainment traditionally uses larger file sizes, M&E uses much larger file sizes, but small file size performance got a tremendous boost as well. And on the next slide, we find that with StorNext5 being so much faster, it takes full advantage of the hardware that our metadata controller server is using, and it is much more agnostic of the kind of transport, the way it's connecting to these clients. So whether it's fiber channel or Ethernet connected or beyond, these are all options in StorNext. The performance is it takes full advantage of the available architecture. The other appliances that we released with StorNext5 are a storage. We call it a storage appliance. It's RAID. It's RAID 6 volumes that you use to build scale-out volumes to support StorNext and serve storage to the users. Well, that's all optimized for StorNext5 and takes advantage of file-based affinities as well to allow people to build custom workflows and get even greater performance. On the next slide, one important feature is that StorNext, we have another product that is often paired with StorNext called Storage Manager. And Storage Manager is a tool that will automatically, based on the rules that you set, move data from tier to tier. And we can now natively write not only to our own file system called ANTF, but to LTFS as well, which in many segments is a really handy way to get data between, say, customers or different groups, or sometimes there's a requirement to archive the LTFS, et cetera, for long-term vaulting. So that's turned out to be a tremendously powerful option for folks. On the next slide, I just want to call out again that architected for the long term, StorNext5 takes full advantage of RAM, the way that the computer is using cache, all the disk I/O, shrinking the metadata. It gives tremendous payoff in performance. We find that when we can fit more in RAM, you can support that many more users. And all in all, we wanted customers that are already on StorNext to have a seamless transition to this next version of StorNext5. On the next slide, we Flash and InfiniBand optimized. When StorNext, this new performance, these new higher levels of performance in StorNext5, means that customers that are ready to use InfiniBand, and that StorNext5 will also take full advantage of SSD on the metadata controller servers as well. So now the file system is fast, and it takes full advantage of faster hardware as well. And then finally, for StorNext5, just to recap, for customers that are already on StorNext5 and appreciate having a cross-platform shared file system that is very fast, we allow them to have more scalability, up to 10 times faster performance, and something that is fast enough to take full advantage of all the different topologies and transports that they have in place in their environment. So on the next slide, just to recap a bit, StorNext is in use. I mean, think of any place you would have the need for teams of users to collaborate in real time on a shared file system. And probably where we have the most traction is in media entertainment, but we also have customers doing a tremendous amount of work in the federal intelligence and surveillance space, and also in life sciences and natural resources. And it's interesting to think that people that research is not done in an island. And in fact, a lot of the very dedicated ways of computing, perhaps on what people think of traditionally as HPC, a big stack of Linux clusters, all the data that they need to compute and move and work on in the resultant sets, all that data needs to be managed and tracked and archived as well. So it turns out it's very, very powerful to have one platform where you can have users sharing collaboratively with rich clients, but also interacting with all the other ways that they compute, perhaps parallel computing, and also with unstructured type of computing as well. But now you have a platform where you can manage the flow of that data back and forth in and out of these different tiers. On the next slide, knowing that we appear as a file system and are fully supported with a number of workflow applications, not only in media and entertainment, but also in oil and gas and other fields as well. We do a tremendous amount of testing and work closely with a number of partners for these rich solutions, these rich collaborative solutions that need to be very closely connected as they're working on problem sets. And some example customers that choose StorNext: oil and gas customers, media and entertainment customers, customers all over the world that recognize the value of working collaboratively on a great platform. Onto the StorNext5 appliance family. Traditionally, data tends to, especially in media entertainment, tends to take this flow from an ingest of raw data that gets transformed in a work in process and then is delivered out to clients. And then once the immediate need for that data has been served, it tends to sit in a nearline repository and then finally to a long-term offsite. And in the past, this has really sort of felt like a one-way sort of transformation of data from raw ingest to final sitting on archive. But in that context, the StorNext file system itself spans all of those different stages of working with data, and we have the StorNext metadata controller servers and StorNext storage appliances that provide that not only manage the users but provide the storage itself. And then we also have nearline storage, our QD disk series are perfectly fit for a very large archive of nearline storage, spinning disk. And then we bridge to tape environments, a managed tape environment called our StorNext AEL archives. And then finally, as mentioned, we can branch off to LTFS. But a really interesting and a new technology and new product for Quantum is called Quantum Lattus. It's been used often as a nearline storage technology. And we can go into that in a few minutes. On the next slide, StorNext5 and StorNext5 availability. It will be initially available this year, and the StorNext5 software-only solutions will be available in the first half of 2014. And then finally, this next section, where we talk about, let's spend a minute and talk about Lattus Next Generation Object Storage. We find that on slide 19 that many of our customers that really are wrestling with big data are finding that it's not just an OpEx problem to be solved. Big data isn't just something to be managed. It turns out that IT managers and anyone managing these collaborative environments needs to balance all these critical things. How long does data live? How long should I keep it around? How fast is it growing? How valuable is it now? How valuable will it be down the road? And how do I keep access to my users? So it's a very difficult place to be. And we find on slide 20 that a lot of the ways that customers are using big data in the past is sort of linear. I ingest a tremendous amount of data. I have to grow my disk storage in an ad hoc fashion, and then ultimately, when the data is no longer immediately of use, then I vault it away. And that was very much felt like a one-way trip sort of exercise, and was very much subject to someone trying to drive down operating costs. When it turns out, a lot of customers are finding that, yes, I ingest this sort of, think of it almost analogous to the internal of a computer, this fast cache, or what's sitting in memory, is the data that I'm currently using immediately to help solve or drive, build a solution or solve a problem. And that data doesn't just get vaulted off away, it will move to a different tier, but that's completely policy-based, and will drive to the lowest TCO, but is still readily at hand. I can pull it back in very quickly for a new data workflow. And this could be, for example, it could be interrogative. It could be, what if? Pull in a giant data set and let's sift through that data, or let me pull in a data set very quickly because I need to repackage it, and it's something that I can now monetize and sell to a customer as long as I can get access to it quickly. And that's very common in media and entertainment environments, for example. So on slide 21, we see that while Quantum has some very good RAID 6 options for building, let's call it this fast cache part of the solution, it's really difficult to build a petabyte scale RAID 6 system. it's very difficult. And today, to get to that size, I would have to use the largest available enterprise class disks. And when a drive fails, as ultimately happens, they're susceptible to heat and noise and vibration. If one of those fail, the time it takes to rebuild that becomes very long, and this problem is not something that's going to be solved immediately. So the challenge remains: how do you make available a fast, very large, up to the petabyte and beyond scale architecture that'll hold all the big data that customers are going to generate? So in slide 22, it turns out that the sort of traditional block addressing and traditional ways of getting to a disk and going down and tunneling down through folders is also not very efficient. And what happens if I have users all over the world and I need to start mashing together all of these different users and all these different apps? So in slide 23, the reason we built Lattus was because our customers, given the rate at which data is growing and the types of challenges they're facing, is that they needed something that would allow them to scale absolutely in any direction. That would give them a completely flat namespace, and hardest of all was how to provide ultimate data integrity, something that allows multiple copies, yet is efficient across multiple storage nodes, and allows you a global data access and accessibility. And our answer is, on slide 24, is that object storage for us is the answer. And it has allowed us to build very, very large, up to petabyte scale and beyond volumes of fast disk that is, you can think of it as disk, that's available to the customers, and it's so useful. Some customers will build it as a private cloud, others will build it as a virtual vault that is still accessible and delivers far beyond RAID 6 level data integrity. And it makes it easy for things like remonetizing that data, because it is very fast to get access to and very flexible to pull data from. And best of all, on slide 25, this is not object storage for object storage sake. It does deliver that integrity, the data integrity, and being able to make the underlying data objects that comprise that data can be spread across multiple nodes, self-healing disk and nodes, but even across different data centers in something we call geospread. But now, pairing that with the StorNext file system that can be managed, well, now Lattus, this very efficient petabyte class storage, is now another very powerful tier, very powerful target for the way that you manage data, and customers have been using it in different ways, and it's just phenomenal technology, and it's very exciting to see where customers are taking this. So that, sir, is our sort of formal overview, but we would love to tuck into any questions about big data and where our customers are pushing and driving.
Well, great. Well, thanks for that, Skip. I'm curious about how you guys handle the metadata. Do you have, in terms of redundancy, right? Do you have separate metadata servers that are in parallel, or how do you put that together?
Great question. Yes. So a concurrent shared file system, the way StorNext works, it does, as you say, it has a metadata controller server, and it keeps track of the not only the files, but the connected users and the privileges and who and what files are open, etc. But each installation, in fact, our metadata controller appliance that serves this function is called, actually under the hood, is a failover. Will fail over from two individual servers. So it's one appliance, but there are two servers underneath, and they will fail over from one to the other should one go offline for any reason. But yes, that's especially especially in the environments that our customers work in, they cannot afford downtime, and it's not truly highly available unless everything's redundant, and that's an important part of that.
Yeah, yeah. And then, Skip, how does this take its form when it's a software-only solution? Do people just cobble together their own JBODs, or what does it typically look like?
So while we will optimize the experience on StorNext provided appliances, many customers over the years have installed StorNext on their own servers and connected to their own storage. So it's initially StorNext5 will be available on StorNext5 appliances. But in the new year, customers that build their own metadata controller appliances will be able to upgrade to StorNext5 as well.
Yeah, yeah. And then in terms of, I'm familiar with I do a lot of video, so nothing eats up data storage like video. Is that your sweet spot? Is lots of large files, or does this architecture lend itself to that unstructured data with those tiny little files in the hundreds of thousands that tend to clog things up?
It's true that some customers have hundreds and hundreds of seats all concurrently using and throwing around giant video files. So we really have gotten a reputation for working best with very large files, but the way StorNext5 handles much smaller files opens up a tremendous amount of deeper traction and opportunity in other industries. So it's very exciting, and we find that customers are wanting to work with data. I mean, once you have that much data in one place and managed by one comprehensive platform, then you can start integrating perhaps these more HPC or unstructured / Hadoop style workflows, and they can sit very nicely and work very closely with your collaborative style workflows. So it really feels like a whole new world.
Yeah, yeah. And then Skip, kind of a wrap up here. In terms of business intelligence, we got a lot of people using Hadoop clusters out there for batch analytics and such. How do you guys work with that? Is there a conduit, or is it policy based, or how does it work?
So there are a couple of ways to. I mean, the key thing is being able to whatever data was generated that you want to maybe start querying or on with Hadoop. That when it's on perhaps a Hadoop node, you still want that data to be managed, whether it's on or off a separate compute architecture, and so it still needs to be managed. Same for HPC. The initial data that you need to analyze, that in itself needs to be managed, as does the resultant set, and then made available to other users throughout your whole enterprise. And that way there aren't these tiny little compute islands that are susceptible to, well, all the things that could possibly happen in an unmanaged environment. Data gets lost, et cetera. So we really look at it as a way to help tie together all these islands and these workflows that were really separate before.
Yeah, yeah. Well, Skip, this is very interesting, and it sounds like the sky's the limit for StorNext5 going forward.
It's definitely been a long road, and the team that we have working on it are exceptional, and it's been almost 3 years of work, and I think they're excited to show the world.
All right. Well, Skip Levens, I want to thank you once again for coming on the show today.
Oh, really appreciate it. Really appreciate it. Thank you for the opportunity.
You bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of big data.